Hi students, welcome to the physics classes. Today we have discussed the lesson laws of motion. First of all, we have discussed what is kinematics. You know that kinematics is a branch of physics which deals with motion and its parameters. You have looked at the slide, has seen a car is moving. There will be not a moving the car. We have assumed that the car is moving. So kinematics, we have already said that kinematics is a study of motion and its parameters. You have assumed that the car is moving, there will be a motion, and the parameters of the motion is the velocity, acceleration, speed, etc. Clear that? Then we have to move on next slide. The Newton's laws describes the causes of motion of force. Kinematics only describes only the motion and its parameters. We have Newton's laws of motion, study not just motion but also cause of motion of force. They will be studying the cause of motion of force. Clear that? And we have to move on next slide. Simple thing is that what is meant by force? Have given two pictures in the slide. First one is a boy is pulled a trolley, and another picture we have seen a girl and boy fight with a donkey. Clear that? There will be the boy is pulled the trolley, and next one the boy is pushed the backside of the donkey, and next one is the girl is pulled. The girl is pulled the rope tied in the neck of the donkey. Okay, so we can say that the force is a some sort of pull and push. Clear that? Force is a some sort of pull and push. Clear that? Then we have discussed force is a vector quantity. You know that force is a vector quantity, which means that force can have magnitude and direction also. Okay. The next one we have discussed, a question arises, the non-living things exerts forces. Yes, of course, we have to see in the slide, there will be a box, there will be a wall, there will be a trolley. These are exerts a force. How this exerts a force? Okay, this exerts a force between these two. There will be a man and a box, so we will exert a force in between two. So non-living things are exerts force. Clear that? Then next we have discussed the fundamental forces. Which are the fundamental forces in the universe? We have now which are the gravitational force and the electromagnetic force. We know that everyone have a gravitational force. This is a phone which have also a gravitational force towards the earth or towards about and next one is electromagnetic force, and next one is strong nuclear forces and weak nuclear forces. These are the fundamental forces in the universe. And this slide is give some little knowledge about which are the fundamental forces. Okay, clear that? Then we have move on to the next slide. Which are the types of forces? We have the two types of forces. Which one is contact force and non-contact force? What is meant by contact force and what is meant by non-contact force? Contact force, which describes that when two interacting objects are physically touching, which means that a pen and a mobile is physically touching, which we can say that the force is contact force. Clear that? And another one is non-contact force. What is meant by non-contact force? There will be a non-physical touching. There will be a force, but they have no physical touching. Clear that? So it describes that when two interacting objects are not touching. Clear that? And give the examples of contacting forces and non-contacting forces. The examples of contacting forces which are friction, applied force, air resistance. Simple thing is that. And Another one is non-contact force, which are examples of non-contact forces are gravity, electromagnetic force, and magnetic force, electric force. These are the examples of non-contact force. How know that magnetic forces, the same poles are repels and the opposite poles are attract to each other. There will be a no contact with them. Okay, clear that? Then we have to move on next. A simple thing is that types of forces, examples of contact and examples of non-contact forces given in this slide. Okay, then we have to move on to the next slide. First one is force of gravity, or we can say that weight. That is, for example, I have a mobile. This have a force exerted downwards towards earth. The force is towards earth. This force is the gravitational force. All things have a gravitational force that is exerted towards the earth or the downwards. The force exerted downwards direction. That is, we can represent W is equal to the weight is equal to mg. Clear that? Then next one is normal reaction. What is meant by normal reaction? That is, normal force or normal reaction is the force that surfaces exert to prevent solid objects from passing through each other. Which means that we have two objects, an object placed in a plane. There will be two forces exerted. One will be the downward force, that is, we have already discussed that, the gravitational force. And in opposite direction there will be a force, the normal force or the normal reaction to opposite the weight of the body. Clear that? In the picture we have to see that the weight mg and downwards and the normal reaction which is in that the upward force. Clear that? And normal reaction or normal force is perpendicular to the surface of contact, which means that we have an object of pen is contact with the mobile. There will be a perpendicular to the plane. Perpendicular. The normal reaction is perpendicular to the plane or the mobile. Clear that? Then next one is describes the normal reaction is seen in different types. Okay, in inclined plane or in a rounded structure. Here in the picture we have to see that there will be a plane. Clear that? There will be a plane. The force exerted downwards means that the weight is downwards and the normal reaction is upwards. So we can write it as N is equal to mg. Clear that? And in an inclined plane, mobile is in inclined plane, so there will be a weight downwards, and this is a perpendicular. Normal reaction is perpendicular to the plane and which is in another way or in another direction. So here N not equal to mg. Clear that? And next picture we have to see that the normal reaction is perpendicular to the point of the plane. That means in a curved plane, in a curved structure, that will be the normal reaction is perpendicular to the point of the plane and the weight is downward. So there will be also N naught is equal to mg. Clear that? And we have to move on next slide. What is meant by tension? Tension is also called a force. Tension is a force which is tension force due to thread, string, wire, rope, etc. Simply we can then tension is another word of force. Force due to a thread or string, wire or a rope. Then you can see that a weight is hanged with a string in a plane. Okay, clear that? Then tension is a contact force. That will be an object and the string is in a contact. Clear that? So tension is a contact force and tension force acts along the thread from the center of the block. That will be the force acts along the thread, the center of the block. We can see that the center of the block. Okay, clear that? And we have moved next slide. Okay, ideal massless thread have same tension throughout, which means that ideal massless, which means that a thin thread or a thin string which have this tension is throughout same. The tension throughout same, which means that massless thread has same tension throughout. Clear that? It's a thin thread is, so the tension throughout the same. And tension throughout the thread is equal to the force applied to one ends it. We have applied a force at one end of a thread. Clear that? We have applied a force at one end of the thread. That describes tension throughout the thread is equal to the force applied at one end. That is, T is equal to the applied force. The tension is equal to the applied force at end. So next we have discussing Newton's laws of motion. We have discussing three laws: Newton's first law of motion, Newton's second law of motion, and Newton's third law of motion. So in the slide you have to see two balls. You have to assume that the one is moving. The one is moving and another one is in stationary. Clear that? So the definition will come that you have next slide you have seen that the definition of Newton's first law of motion. So simple thing is that an object in the state of rest or motion continues to be in that state unless and until give an external force on it. That means the body is in stationary and another body is in a moving condition. The stationary ball will move when we give an external force upon it. You can got it? And another one is moving in a uniform motion. When it stops, we give an force upon the ball. So Newton's first law of motion is describes that an object in the state of motion or in a uniform motion or in a state of rest, that state unless and until give an external force acts on it. Clear that? Here with no outside force, a stationary object will remain same. That means it continues in a state of rest unless give an external force on it. And second one is in a uniform motion. Second one is in a uniform motion. That is, with no outside force, a moving object will not stop. This is Newton's first law. So in other words, we can call that Newton's law of inertia. The Newton's first law of motion is called law of inertia. Okay, what is meant by inertia? Simply we can say that inertia is an inability. Okay, the definition will come the property of a matter by which it continues in existing state of a rest or uniform motion in a straight line, unless that state is changed by an external force. Okay, clear that? And some kind of things that related to inertia are the point out in the slide. You can read it out simply. An inherent property of all the bodies by virtue of they cannot change. They cannot change their state of rest or uniform motion along a straight line by their own is called inertia. It's an inability to change its position, its on, which means that it continues in a rest, it cannot change in the position, the rest position, it's on. Or in a uniform motion, it cannot change the position, or uniform motion, it cannot change by its own. Clear that? Then next one is inertia has no units and no dimension. Okay, then we have to move on next slide. It's a picture of inertia of rest. We can pull the plate and the egg above the plate is down the glass. It's an experiment that related to inertia of rest. Inertia of rest, which means that it is the inability of a body to change by itself at a state of rest, which means that it is the inability to change its state by its state of rest. It's called inertia of rest. The examples are given below. Examples: a person who is standing freely in bus, thrown backward when bus starts suddenly, is an example of inertia of rest. He is sitting in a seat and bus will move, he will bend forward or backward. So he cannot change its own position or its own state. It's an example of inertia of rest. Okay. Next one is inertia of motion. Is an example. Is a picture shows that is a moving. It's continuously moving. That is continuously moving. They cannot change their state. It's on. It is continuously moving. It cannot change its on, its position or its state. It's on. Okay. What is the definition is comes that it is the inability of a body to change itself state of uniform motion. That means it cannot change its state of uniform motion by itself. It is an inability. Clear that? Then examples are given below. 3 examples are given below. When a bus or train stops suddenly, the passenger sitting inside tends to fall forward. Clear that? Then next one is person jumping out of a moving train by fall forward. Okay, the next one, an athlete runs a certain distance before taking a long jump. This is because of velocity acquired by running added to the velocity of the athlete at the time of jumping. He acquires the velocity to jump. Okay, then hence he can jump over a long distance. And these are the examples of inertia of motion. Clear that? And we are moving on. Next one is inertia of direction. We have already discussed first of all inertia of rest and inertia of motion. The third one is inertia of direction, which means that it cannot change itself by the direction. That is, it is the inability of a body changed by itself direction of motion. Examples are given below. When a stone is tied to one end of a string is wired and the string breaks suddenly, the stone flies off along a tangent of the circle. The next one is given a rotating wheel of any vehicle throw out of mud if any tangentially due to direction of inertia. Okay, clear that? And next example is when a car goes around curve suddenly and the person sitting inside the thrown outwards. Okay, 3 examples of inertia of direction, which means that inertia of direction, which means that inability to change its direction, it's by itself. Clear that? And we have moving on. Next one is linear momentum. Linear momentum is a property, which means that the property is a momentum is a property is a characteristic of motion of an object. Is described by P is equal to mv, which means that P, which means the linear momentum, which is the product of mass and velocity. So which can represented by P is equal to mv. Then slide is given the notes. Linear momentum of a body is the quantity of motion contained in the body. Okay, and next one is it is measured in terms of force required to stop the body in unit time. Okay, then it is measured the product of mass and velocity. That is momentum, linear momentum is equal to mass into velocity. Then if the body of mass m and the velocity v, we can represent it by the linear momentum P is equal to m into v. That is P is equal to where P is a vector quantity and also velocity is a vector quantity. Clear that? And we have next, and it's a vector quantity, and already says that linear momentum is a vector quantity and its direction as the same as the direction of velocity. It's an important, the direction of momentum is the direction of velocity, is same as direction of velocity. That is P is a vector quantity and v is also a vector quantity. The direction of momentum is same as direction of velocity. Clear that? And its units are kilogram meter per second in SI unit and in CGS gram centimeter per second. Clear that? And its dimensional formula is mlt raised to minus 1. mlt raised to minus 1. And this is all about the linear momentum. Okay. And we have described 3 types of graph in the linear momentum. which is related to P, that is mean momentum, mass and velocity. This relation between momentum, mass and velocity. First of all, we have described the relation between momentum and velocity, where m is a constant. So in this diagram we have seen that the relation between momentum and velocity in a directly proportionality. That is, the graph is given a straight line. Gives a straight line, which means that P proportional to V. We have already said that P proportional to V, where m is a constant, mass is a constant, then P directly proportional to V. So in x-axis we can see that velocity, and y-axis we can see that the momentum. There will be velocity and momentum is directly proportional when m is a constant. Okay, the first graph is described by when m is a constant and P proportional to V. Okay, the next one is for different bodies. Okay, we can take it as for different bodies, and a pen, and another one is for different bodies at same velocity. We have different body but same velocity. Then there will be V is a constant. There will be V is constant. There will be also a graph given by a straight line between momentum and mass. Clear that? There will be V is constant in different bodies. V is constant. And then P proportional to m. That means momentum is proportional to mass. Clear that? And next graph is described by if two objects of different masses. Clear that? If two objects, we have two objects, m1, m2 is the masses, and have same velocity. Have the same velocity, V is the same velocity, and V1 is equal to V2 is equal to etc. is equal to V. That is, an higher body possesses given a greater velocity. That is, we can write as P is equal to m1, V1 is equal to m2, V2 is equal to a constant. That is, we can write as V2 by V1 is equal to m2 by m1. That is, we can write it as V proportional to 1 by m, where P is a constant. Okay, where V proportional to 1 by m, or we can say that V inversely proportional to m. That means a lighter body possesses a greater velocity. The mass, when mass decreases, when velocity increases. When mass increases, when velocity decreases. There is an inverse relation between velocity and masses. A higher body masses consists of lower velocity. That means a lighter body possesses greater velocity. Another one is clear that the graph is given by velocity and mass graph is given by various P is a constant. There will be an inverse relation. That graph will give an inverse relation between the two. And next we have discussed Newton's second law of motion. In this picture you have to see a boy pull a car. There will be a force given and acceleration have get. And another picture, there will be a double the force and for acceleration is also doubled. Okay, this thing is related to Newton's second law of motion. And describe what is Newton's second law of motion. There will be the rate of change of momentum is directly proportional to the external force add. Clear that? The definition that gives the rate of change of linear momentum of a body is directly proportional to the external force applied on the body. It is Newton's second law. And an external point is added, and the change taken place always in the direction of applied force. Clear that? First of all, what is Newton's second law? Says that an applied force is directly proportional to the rate of change of linear momentum. And second point is change taken place always in the direction of applied force. The change in direction is taken place, we have applied a force. Okay, clear that? And the derivation of second law is clear that if a body of mass m and moving with the velocity v, okay, clear that? And the linear momentum can be written as p is equal to mv. P is equal to mv. Then we have already said that the applied force is directly proportional to the rate of change of momentum, and we can write it as F directly proportional to dp by dt. dp by dt, which means that rate of change of momentum, and we can write it as F is equal to k dp by dt. Okay, F is equal to k dp by dt, and we can write it as F is equal to, when k is equal to 1, assume is equal to k is equal to 1, we can write that F is equal to dp by dt. And we have to know that P is equal to mv, then equation is rewrite F is equal to d by dt of mv. Okay, and it is equal to m into dv by dt, that is equal to ma, that is equal to F is equal to ma, where we know that F is equal to a vector quantity and also acceleration is a vector quantity. So this is the derivation of second law of motion. First of all, we have considering a body of mass m with moving a velocity of v, and we can write as in terms of momentum p is equal to mv. Then we can write it out in terms of force F is equal to dp by dt, where dp by dt is equal to rate of change of momentum. Okay, then F is equal to k dp by dt, and rate is k is equal to 1, F is equal to dp by dt. And we know that P is equal to mv, and substitute it, that is equal to F is equal to d by dt of mv. And it is separated, we can get m is equal to dv by dt, that is equal to, there is dv by dt is equal to change in rate of change of velocity, that is equal to acceleration, that given F is equal to ma. This is the derivation of second law of motion, and we have to move third law of motion. We have moved third law of motion. What is third law of motion? You have fired a bullet from it. Okay, there will be a force exerted backward. So Newton's third law is described as every action there is equal and opposite reaction. A simple thing that. And the main point is noted in the third law. These are the 5 points are noted in the third law. So first one is action reaction pair of same magnitude, which means the action reaction have same magnitude, which represent the same magnitude. Okay, then second one is action reaction pair act in opposite direction. The action reaction as act in opposite direction, we can see that the direction is opposite. Okay, then action reaction pair act on a different bodies. Act on the action is act on it, and the reaction is act on it, so it's in a different bodies. And then next is action reaction pair act simultaneously. It acts simultaneously. Okay, the next one is action reaction pair are same nature. Okay, clear that the 5 points are described, or the important things regarding the Newton's third law. The question arises from that, the 5 points action reaction pairs are equal, same magnitude. Then next one is opposite direction. There are in opposite direction and act on different bodies, and two are act simultaneously and are of same nature. Okay, clear that? And we have moved to next topic, free body diagram. Okay, free body diagram. How to draw a free body diagram? So simple thing is that how to draw a free body diagram. You can ask many questions to draw a free body diagram. The thing is related to the free body diagram. First one is assume all objects to be a point particle. Assume it's an object. Assume all objects to be a point particle. Okay, next one is weight mg acting downward, vertically downwards. That means mg acting vertically downwards. and check all surface of block and apply contact force of each physical contact of the block. Okay, the next one is keep all forces tail to tail. There will be a force of normal reaction, that is N. There will be a N. So this is a tail to tail. Okay, keep forces tail to tail. For an example, we have to give a body placed in a surface. Okay, and draw a free body diagram. A masses of 3 kilogram. Draw a free body diagram in this picture, and we can write as there will be a force mg acts on downwards vertically, mg, and a force, a normal force, a normal reaction. So a force acting downward. A simply is a free body diagram of this diagram. Okay, clear that? And we have discussed a simple method in another way, and we have discussed it in later. Okay. And next one is we have discussed about the concept of pulley. We have seen that the concept of pulley and the main point, ideal mass thread has same tension throughout, which means the thread have ideal same tension, the massless thread, which means a thin thread which have same tension throughout it contains same tension. There will be no change in tension. And massless and frictionless we have discussed in the case massless and frictionless pulley. As a string is which is massless and frictionless. Okay, then we have the concept is that we have a body, we have a mass and another body the same mass m, and there will be an also use of pulley. The force is applied the direction. In this direction we have applied the force, and more force will be applied to lift the body mass m. Okay, then we have applied a pulley here. We have applied a pulley here, and the direction of force is this. Clear that? And there is a direction change. So next we have discussed about Atwood's machine. So Atwood's machine is an arrangement of 2 blocks tied to an ideal thread going over a frictionless pulley. Okay, simple thing that there will be a mass m1 and m2. It is attached by a string through a pulley. So we will have a simple common sense things that m1 is equal to m2. m1 is equal to m2, where the mass is same. m1 is equal to m2. That is, there will be no motion. m1 is equal to m2, that means that weight is equal to same. So there will be no motion. So another thing is that the m1 greater than m2, what will be happen? m1 is greater than m2. There will be a force acting m1. The m1 is coming downwards because of weight is bigger in m1. It's a simple thing. Then there will be m2 greater than m1. What will happen? The m2 is more weight, that the m2 give a force on downward. So m2 coming downward. So in these cases we have how to find the acceleration and the tension. So the question is arising to find the acceleration and find the tension. How to find the acceleration and the tension? So we have already said m2 is greater than m1. So how to be find the acceleration? We have now F is equal to mg plus or minus a. We have already learned that. Clear? Then how to be find a? That is a is equal to the net force, F net, the net force acting on it divided by the total mass. Divided by the total mass. So find the acceleration. The definition that the net force acting on it and the total mass. The body M1 have M2 to bring the total mass. So F net is given to, that is M2G. We have the force M2G minus M1G. Clear that? M2G minus M1G is divided by M1 plus M2 is the total mass. So we can write it as A is equal to, we can write it as G is outside M2 minus M1 divided by M1 plus M2. Clear that? The acceleration, find the acceleration in the body. So G into M1 M2, M2 minus M1 divided by M1 plus M2. This is the equation of acceleration. How to find the acceleration in the body. A simple thing. And we have to find next the tension in the string. How to find the tension in the string? It's a simple thing that. So we have to find the tension in the string. The tension in the string. How will we find the tension in the string? That is, we have to considering the motion of M1 downwards. We have to considering the motion M1 downwards. Then we have how to find the tension. T is equal to M1 G minus A. Because of M1 G minus A, which means that the A plus or we have already said that F is equal to mg plus or minus a. Here the coming minus a. So T is equal to m1 g minus a, then which is equal to m1 g minus a. We have already get it that m2 g minus m1 g divided by m1 plus m2. Clear that? And we can write it as m1, then we can write it as m1g plus m2g minus m1g plus m2g. Clear that? Divided by m1 plus m2. And we can write it as T is equal to m1 to m2g divided by m1 plus m2. Clear that? And we can rearrange that T is equal to 2 m1 m2g divided by m1 plus m2. So this is the equation for finding tension.